Hello and welcome back to JD Science Prep. Today I'm going to give you a quick introduction to how ionic compounds bond. So I'll give you a quick description and then we'll go through a few examples looking at some Lewis dot diagrams to really establish this idea. So in short, ionic compounds will occur between a metal and a non-metal. So a metal is, when it's in its ionic form, it is a cation, so it will be a positively charged ion. And a nonmetal, when it is in its ionic form, it is a negatively charged ion. So we can call those anions. So positive ions are cations and negatively charged ions are anions. So the positively charged cation will donate its valence electrons to the negatively charged anion in order to empty its valence shell. So remember, all elements eventually want to fulfill the octet rule, so they want to have full valence shells. So because metals or cations have a low number of valence electrons, they will want to lose them because it's a lot easier to lose their electrons than it is to gain and fill its shell. On the flip side of that, anions will want to take those valence electrons away from cations because they generally have more valence electrons. So it's easier for them to gain rather than lose. Okay? So some examples here. The first one we have is when the sodium ion and the chloride ion will bond together. So let's just take a look at the behavior of our electrons between sodium and chloride. So as you can see, Na or sodium will have one valence electron. It is represented by this red dot here. And chlorine, right here, if you look on your periodic table, has 7 valence electrons. So what happens between these two is sodium is going to want to lose its one valence electron, because if it loses it, it now has a full valence shell. So when sodium loses this electron here, chlorine is going to want to gain it because all it needs is one more electron and then it has a full valence shell. So let's redraw this here. I'll just use white to represent sodium. So we have Na, and since it lost its one valence electron, it now lost a negative charge. So its overall charge, I guess we don't need the brackets here. We can erase the brackets. We can just write that Na has a positive charge. Now we cannot forget about what happened to Cl here. So Cl gained one electron, so we have to draw all of its valence electrons now. Actually, I'm going to switch the one it gained to a different color. I'll switch it to red. There we go. So this red electron is the one that chlorine gained, and since it's now a charged atom, it is an ion. So because it gained an electron here, it gained a negative charge, so we will represent that by putting a little negative sign right there. Okay, so we have Na plus and we have Cl negative, and when they bond together they will create NaCl. All right. So it cannot be, or it just doesn't have to be two atoms. Ionic bonds can happen between 3 or more atoms as well, or ions, sorry. So let's take a look at when we have 2 fluorines and 1 calcium. So as you can probably guess, calcium is going to be our cation, okay, and our 2 fluorines will end up being our anions. Okay, so calcium if you look on your periodic table, has 2 valence electrons. So what's going to happen to those 2 valence electrons? One will be donated to one fluorine, and the other will be donated to the other fluorine. So now all of a sudden, we no longer have Ca with 2 valence electrons. We have Ca, and it emptied its valence shell. So now it's the calcium ion. And because it lost 2 valence electrons, let me just draw this out here. I'm just going to split it up with a quick line. Let's see. There we go. I'll split it up with a line here. We have Ca, and it lost 2 negative charges. So that means it's now going to be Ca2+. And we have 2 fluorine atoms that each gained 1 electron. So now those will be fluoride anions. Right? So we have 1 fluoride, and I'll draw all its valence electrons. And again, this 1 it gained from calcium, and I'll draw our other fluorine, or fluoride, sorry. So we have 1, 2, 3, 4, 5, 6, 7, and the last one was completely donated from our calcium. So now these 2 fluorines, or fluorides, sorry, will have a negative charge. Okay, so again, calcium just has that 2+ charge because it lost 2 negative charges. And because the fluorines both gained 1 electron, they will have a -1 charge. All right, and our last example here, we have oxygen and magnesium reacting with one another. So you can probably guess oxygen will end up being our negatively charged ion, or anion, and magnesium will be our cation. So let's see here. This electron from magnesium will be completely donated to oxygen, and this valence electron will also be completely donated to oxygen, and I'll just split it up with a quick line here. So the first thing I will draw is just our magnesium ion. So it lost 2 valence electrons, it lost 2 negative charges, which means it has a overall 2+ charge now. And oxygen gained 2 electrons, so I will just write out our oxygen here, and keeping with our pattern, we will have 6 of its own electrons, but then it received 2 valence electrons from magnesium. So overall oxygen will now have a 2 negative charge. Okay, so again, I really want to stress that when we're looking at ionic compounds, it is a complete transfer of electrons from the cation to the anion, and you must make sure to write down the charges of your ions when creating Lewis dot diagrams. Okay, I hope this helped.